So I thought what we'd start with today, we're not going to, of course, spend a lot of time on this because I know we want to do some math today, get ready for the test, but I thought we'd spend a little time on how I'm crunching your grade at the end of the semester, just so it isn't a mystery to any of you. And of course, I'll post this as always after class, so you don't need to be writing all this down right now or memorizing this. This is just what I'm going to do. So there were 22 pre-work assignments. You might remember that one of our sections didn't have a pre-work assignment to go with it. So there are 22 pre-work assignments. So at the end of the semester, what I do is I add up all of those and divide by 22, and that gives me your pre-work score between 0 and 100, hopefully closer to 100 than 0. Then I add all your build understanding homework scores. There were 23 of those, divide by 23, and I get a build understanding homework score somewhere between 0 and 100. Once again, closer, hopefully closer to 100. Then I add your best 3 quiz scores and divide by 3 to get your quiz score. Note, when you look at your grade book at the end of the semester and you're looking at all the grades, you're still going to see all 4 quiz grades in there. I only used the best 3, though, to get your final quiz score. So don't freak out if you're like, I thought he was going to get rid of that 0. I did. They all stay in there in the grade book, so there's a record of them. Just so we're all clear on how this replacement works with the final exam, the final will always count for itself. So you're going to get the grade on the final. And then if your final is not your lowest exam score, it will replace your lowest exam score and it will count for that exam and itself. If your final, if you don't do well on the final and that ends up being your lowest, then it just counts for itself. So what I did here is I did a couple of examples just so you'd see what I mean by that. So if these were your scores, and if these match yours, I'm terribly sorry. I'm not trying to show your grades terrible. It's pure coincidence. If you got like a 34 in the first exam, didn't do so well, but then you really picked up your game here, what's going to happen is this 73 is actually going to replace this 34 down here. Now you're still going to see the low grade in the grade book, but I'm not using it. I am using the final exam score. Or if you're one of the students that had to miss a class and you have a 0, absolutely the final exam will replace that 0 because that will be your lowest exam score. So that 0 will disappear. If the final ends up being your lowest exam, it will still count for itself. It just will not replace one of these over here. So the replacement is only done if it helps you. It's a good thing only, never a bad thing. Just a reminder to all of you, all the exam scores will still appear in the grade book. That's why I wrote what you see. So if you have that 0, you'll still see that 0 there, but just know that the final swooped in and saved the day. But you will still see all of them in there. All right. The syllabus that was available at the beginning of the semester told you how I did the grades for the semester. So pre-work's worth 5%, build understanding 15, quizzes 10. Each of the unit exams was 16, the final exams were 22%. Hopefully those aren't a mystery to anyone. They were on the syllabus. And then what happens is I just do a percent breakdown. So I do your pre-homework score times 5%, your build understanding times 15, quizzes times 10, each of your exams times 16%, and then your final exam times 22%. My decimal didn't get carried over. So what that means is, with the replacement, it means if you were getting an exam replaced, for instance, if exam 2 was your lowest, what the formula is actually going to do is it's going to get rid of that, and it's also going to put the final exam in that spot right there. And that's what it says here, where exam 1, 2, or 3 could be replaced by the final if it benefits the student. I use standard rules of rounding, so technically a 79.5 is a B and 79.4 is a C. Usually if you have a 79.4, though, I go back through and double check your exam if you're really that close, but make sure I didn't make a mistake. I'm not allowed to just give you points, but I am allowed to go back through and review and see if you actually earned something that I marked off. Okay. I am going to post your grades on Tuesday, December 14th. I usually don't post grades until I have all the grades done, and I am giving a test on Monday also. So I will be posting your grades on Tuesday, December 14th afternoon. I actually hope to get it up there by 12, so right around noon. And then 2 days later, I submit them to the college. Once I submit to them to college, that's not saying that they can't be changed if I made a mistake, but it's much easier if I made a mistake to change it before I submit them to the college. So If I submit them to the college and you write me an email and say, Steve, you made a mistake in my grade, I got an 80% on the test, you have a 60% recorded for me, what gives, and I made the mistake, then of course I will do all the paperwork to change your grade, because it's my mistake, my problem. But what I'm telling you is, it will happen a lot faster if you tell me in these 2-day period, if I did make a mistake. So if you believe there is an error in your grade, then please, please, please make sure you email me Tuesday or Wednesday so I can fix it before I submit it to the college. That way it's a lot easier to change it and everyone's happier. And this is not me trying to be a jerk, this is just how it works here at Front Range. I am not allowed to change grades because you were really close or worked really hard. I'm not allowed to grade on effort. I'm not allowed to just give you a couple extra percentage points to push you over. I'm not allowed to consider participation or attendance. So if you end up with a 58% in this class and you're like, Steve, I really need at least a D in this class, I'm not allowed to say, well, I'll give you those 2 percentage points just because you came every day. I can't do it. I'm not allowed to. Because what happens is if I change a grade, then I get asked, why did you change that grade? And I can't say because the student asked me to. I am not allowed to reopen old assignments or give extra credit just to help you pass. That's actually a college policy also. And I do not return your final exams, but if you are very curious, like you're like, I nailed that exam and then you get a 4 on it, no one's gonna get a 4. You are welcome to come visit me in my office and I will let you look through it. I'll answer any questions you have, but I hold on to the final exams for my records. But that doesn't mean you're not allowed to come see it. So if for some reason you do want to come see your final, then please let me know and we'll come up with a time for you to come see it. All right. The other thing I want to tell you is I'm going to do another review this afternoon for my 1 o'clock class. And then tomorrow on Wednesday, I'm doing reviews for a couple other college algebra classes. It is possible that one of those students in one of those classes might ask a very good question that we didn't have time for or no one asked in here. So it would not hurt you, and it's not my intention to tell them something different than I'm telling you, but it would not hurt you to also check out the notes from those other classes just to see, oh, look at this. At the end of their notes, they had an extra 5 minutes and Steve did an extra example that we didn't get to see. So it would not hurt you to go back and look at their notes before you take the test. And as I said, I am not trying to keep secrets from any of my classes, but you never know what's going to happen in there. And someone might say like, hey, Steve, can you do a problem like this? And we'll do a really good problem, and then I want you to be able to see it too. Okay, any questions or comments so far? All right. So let's talk about the cumulative portion of your exam. It's basically the first half of your exam is the cumulative portion of the exam. And there's a large number of quick 1-point questions, multiple choice, true, false, short answer, quick fill in the blank problems. Because they're only worth 1 point, there's quite a few of them. And because there's quite a few of them, you're going to run out of time if you spend 5 minutes on each 1-point question. And I don't want anyone running out of time on this test. I've taken this test 3 times already. I think it's a fair test. I think it's a fair length, but it does not allow for people to spend, a lot of time on each 1-point question. So we're just going to talk about this briefly. If you want to keep from running out of time on these 1-point questions, here's what you need to do. You either need to answer them in less than a minute, if they're a 1-point question. You need to skip it and return it when you have extra time. Maybe you'll have an extra 20 minutes at the end. You can go back and spend some more time on the harder ones. And remember, and I don't suggest this being your first thing you try, but there is no penalty for guessing, so please do not leave anything blank. The worst thing I ever saw was I gave a true-false question once, and someone, rather than just guessing true or false, wrote next to it, I have no idea. So it wasn't like they forgot to do it or they ran out of time. They actually had time to write, I have no idea, but didn't bother to circle an answer. So take a guess. Make me work for my grading. Don't just leave it blank, because grading blank exams is the easiest thing for me. So this is what I mean by 1-point questions. These are things that you should not have to spend 20 minutes trying to figure out, or even 5 minutes. These are things you should either read it, know the answer, mark it down, and move on, or skip it and come back to it later when you have more time. For instance, the range of all even degree polynomials is negative infinity to infinity. The range, is that true or false? That is false. You could say the range of all odd degree polynomials is negative infinity to infinity, or you could say the domain of all polynomials is negative infinity to infinity. But the range of an even degree polynomial is never negative infinity to infinity, because they either go up on both sides or down on both sides. Now, maybe you get that right, maybe you get it wrong, but you don't spend 10 minutes trying to figure that out. Then you move on to another question. It says the vertex of this quadratic is given by which one of these choices down here? Which one is it, the first, second, third, or fourth? And what do we have to remember? When we're doing the vertex of a quadratic, you switch the sign on x, but not on y. Does that sound familiar to everyone? So it's going to be this one. And these are the kind of questions you're going to see a lot of in the cumulative part of the exam. These quick questions here. A one-to-one function and its inverse are reflections over what line? And it wants an equation, not a description or a picture. So what is the line you reflect over to get an inverse?
Y equals x.
Y equals x. Yep. Now, if you go back and retake your old exams, which hopefully you've started already, but if you haven't, because you've been super busy and you were planning on doing your study in the next couple days, I'm not judging or anything like that, make sure you go back over and look at them, because you'll see questions on those exams that tell you how to answer these. I think this is from an old exam. There's definitely some parts where you're supposed to find a vertex on one of the old exams, and there's definitely a part that talks about the range of polynomials on exams. So make sure you go back and retake the old exams, because while you might not see the exact same questions that you see on the final, you will see things that help you answer the questions on the final. So if you're doing something like this, if this was a part of the final, you really shouldn't be spending any more than 3 minutes on this unless you've already finished the rest of the exam and you came back to spend a little more time on it. That's okay. But I don't want anyone looking up at the clock and seeing hours pass and they're only done page 1 of the exam. That'd be the pits. Questions or comments on that? Okay. Next, I want to talk about, we've done a lot of work with different notation and we need to be very precise with our notation in this class, so I don't want anyone missing questions on the exam because they're not answering in a correct format or they're being sloppy. So let's say you're doing a 1-point question and the answer is this ordered pair right here, -3, 2, and the question asks for an ordered pair. Then, unfortunately, every one of these answers is wrong. Because ordered pair, the order makes a difference. If it asks for an ordered pair, you're not allowed to just give me the x and y value, even though, yes, you are giving me the correct x and y value, it's asking for an ordered pair. So this isn't correct. Ordered pairs need parentheses. You cannot forget your second parenthesis, and ordered pairs never use brackets. So please make sure you're paying attention to the notation, because as I said, the problem is in math, if you write something different, it often means something different. So we got to make sure that we're precise. And we've all been doing this class for enough weeks now that we can write an ordered pair correctly. If the correct answer to a 1-point question, if it's asking for a vertical asymptote, and this is the correct answer, x equals 2, and it was asking for the equation of the vertical asymptote, then it is not enough just to say 2. That's not an equation. You can't say y equals 2, because that'd be a horizontal asymptote. And you can't say VA equals 2, because that's not an equation. And even though with this one I know exactly what you mean, that's not how we write an equation of a vertical line. With a vertical line, you could say this would be all right. But you do need that x equals 2 in there. There are some parts where you might need to talk about increasing, decreasing, or constant intervals. All right, this we have not done in a while. So this is something that you might have forgotten some of the details and some of the kind of the little pieces involved. You got to use x values when you're doing increasing and decreasing constant, never y values. You always go left to right, use parentheses only, and you join multiple intervals with commas. So you may not use y values for increasing, decreasing, and constant. Y values you might use if you're doing range, but we're not talking about domain and range right now. You may not use brackets, you may not use the union symbol. Now when you're doing domain and range, then you could be using parentheses or brackets, you could be using y values. So just make sure you take a look at that and remember some of the subtleties involved with doing intervals, whether or not you're doing domain and range, or increasing, decreasing, and constant. All right. Oh, so here's a big thing right here that I can't have you doing. So let's say you're doing an interval And the answer is 3 to 12. You're writing the interval from 3 to 12. Not an ordered pair, but an interval. Please do not do this. And say, Steve will never know if I mean parentheses or brackets, so he's got to mark it right. That's terrible. And don't do this. This one I think people do on accident sometimes because they don't realize that I don't know which one they wrote first. But if the correct answer is 3 to 12 with parentheses, and I can't tell if you meant parentheses or brackets, then I got to mark it wrong, just because I don't know what you mean. Now, if you need to, put a big black X through it and write the correct answer next to it, that's okay. If you need to see that. I see people who take the pen in multiple choice, and they get the multiple choice wrong, and they X it out, and they circle the right one, they write a little arrow that says this one. I'm fine with that. That's fine. Just make it very clear what you mean is your answer. The other thing is we all know that some decimals are the same as fractions and some things are not. You cannot give me a choice between two answers that are not the same thing. If you say the answer to this is 1/3 or 0.33, 1/3 and 0.33 are not the same thing. So it is incorrect to write that and say, Steve, your choice. No, if I'm asking for an answer, I want the 1/3, not the 0.33. If I'm asking for an equation for a line, and it does say an equation, if it does say I want an equation, then you cannot leave off the y equals, because that's not an equation, that's an expression. And you cannot, once again, use a decimal that does not mean the same thing as the fraction. Now, I am fine with decimals and fractions that are the same thing. If I expected the answer to be 1/4 and you wrote 0.25, that's fantastic. I'll give you full credit for that. If I wanted the answer to be 1/2 and you wrote 0.5, then you're awesome and you win. If I want the answer to be 2/3 and you write 0.67, then no, you can't do that because they're not the same thing. So there's no reason to write decimals when we can give an exact answer with a fraction. And of course there are times when you're asked for a decimal, where it says give a decimal rounded to 4 places, and that's fine. But unless rounding instructions are given, like round to 4 places, don't give rounded decimals. Give an exact answer. That's a good thing. That's a good tip-off. If you're supposed to round on a problem, it should tell you what to round to. If it's not telling you what to round to, then you're not rounding on that one. All right, so make sure when you take the test, you're being precise with your notation. Make sure you're not overwriting something where I can't tell what you meant. And make sure you're not spending too long on the short problems. Because there's a few longer ones, and we'll look at some examples of some longer types of problems you might see. But a lot of these are 1-point questions, and you got to make sure you get through them fast. This is the problem. I wrote it on the board over there also, but in case you can't see that over there. Somehow when I changed your practice test from a Word file that I typed it in to a PDF, this equation got swallowed up. I don't know what happened to it. It just disappeared because it's still on my answer key, but it's not on the PDF that I posted for you, or I brought a bunch of copies of today. So those are the instructions for it, in case you were wondering, what am I supposed to do with this grid? All right. So I think what we'll do is we're going to look at the practice test together. Number 3 on your practice test is asking all about a quadratic. So we're not necessarily going to be able to graph it because we can't do all the graphs ever on this exam because we'll run out of time if we try to do all the graphs we've learned. But we can answer questions about something. So what we need to worry about, and you can look down and see number 4, which we're going to do right after this one. If you look at it, we've got 2 basic forms of quadratic. The ones that are in this form, the ax squared plus bx plus c, and the other form where it's a times x minus h squared plus k. All right, everyone. Domain. Is that a throwaway question for a quadratic? Because what's the domain for every quadratic ever? Negative infinity to infinity. Very good. The direction it opens is not a throwaway question. There's two possible choices, but there is just one small thing you have to look at. Who wants to tell me what you look at to find the way it opens? What do you look for? Yeah, the sign of the leading coefficient. The sign of the leading coefficient. So you look at this 2 right here, and because that's positive, that's what tells you that this one opens up. The vertex takes a little bit more work on this one, because the vertex is not just thrown to you. You got to find the vertex. And what's the special formula we use to get started with the vertex? Negative b over 2a. Well done. So we do negative b over 2a, which means we do negative 12 over 2 times 2, and we get negative 3. Now, we all know that's not the vertex. That is the x value of the vertex. If you want the y value of the vertex, you got to plug that into the function and crunch out a number. So we know it starts with a negative 3, and then we do negative 3 squared, we multiply that by 2, then we subtract 12 times 3, or plus 12 times negative 3, and then we add 10. And when all the dust settles, who has an answer for me? It is negative 8. Good job. Yeah. Axis of symmetry does not have to give you a headache. The axis of symmetry is right there once you figured out your vertex. The axis of symmetry is a vertical line. So it's definitely going to be x equals. And it's going to be the same as what every time? The x value of the vertex, yes. So it's x equals negative 3. How about the range? Are we able to do the range without doing a complete graph? Is that possible to do a range without drawing the whole graph?
Yeah, we know the vertex.
Yeah, we know the vertex, and we know which way this thing opens. So every parabola is either going to go up to infinity or down to negative infinity. What is this one going to do? Up to infinity. And the lowest it ever gets to is a y value. And it is the y value of the vertex. So we actually use that negative 8 right there. Please pay close attention to where I'm using brackets, because this thing does get down to negative 8. That is the lowest value it gets to, and it does make it there, so that's why I use a bracket on that, not a parenthesis. The vertex was an ordered pair. That's why that gets parentheses. Ordered pairs always have parentheses. The y-intercept is right in your face. It's right in front of you. You just need to know where to find it. Because what you do to get a y-intercept is you plug in a 0 for everything. And what's the only thing that survives when you plug in a 0 for everything? The 10. But you do need to make sure you write it as an ordered pair. X-intercepts. Well, the x-intercepts are found by setting the equation equal to 0. Now, if it does not specify the technique you're supposed to use, then you basically have 3 ways to find the x-intercepts. You could either try to factor this thing, you could use the quadratic formula, or you could complete the square. This one I actually think made it so you could factor it. But the secret to factoring this one is to pull out that greatest common factor first. Everyone see how you can pull a 2 out of this one? And if you do that, it's going to be a lot easier to factor this sucker. In fact, if you pull that 2 out in front, it almost jumps out at you, because if you're going to factor this, it's going to have to be x and x. Everything's positive, so it's going to be plus and plus. And there's only one way to multiply and get 5, and what is that? Multiply. 5 and 1, yeah. Got to multiply to 5 and add to 6, yeah. Yeah, absolutely you're right. If I had the 5 and the 6 opposite, then it would be 2 and 3. All right, now remember, those are not your x-intercepts. Those are your factors. You got to turn those factors into zeros, and then turn the zeros into x-intercepts. And most people would do that, you know, kind of in their head, but I'm going to show all the steps. So you turn them into zeros, and then you turn them into X-intercepts. So even if there is no graph required, I can still answer a bunch of questions. There's still a lot we can do with this quadratic, even if you're not required to draw the full graph. A lot of information to find out there. This is your review day. I'm not trying to put the burden on you by the way I said it. I'm just saying if you have questions over one of these when we do it, it's a good time to ask. Let's do the other one. Let's do the other quadratic and see how it's going to change our game plan if we're given one in another form. So this is still a quadratic. Its graph would still be a parabola if we were to draw it. We just need to handle this one a little bit differently. First question doesn't change. The domain of every quadratic, unless it specifically tells you it's a story problem or it specifically restricts the domain on its own, but if it doesn't specify anything, you just assume it's negative infinity to infinity. It's still the leading coefficient that tells you the way it opens, and it's still the first thing you see. It just happens to be in front of the parentheses for this one. And since that's a negative number, this particular parabola would open down. Vertex. You don't use the negative b over 2a formula. In fact, I'm so adamant that I don't want you to use that on this one that I'm going to write it and then X it out. We don't use that. The vertex should actually just be right in front of us. You just need to make sure that you change the right sign. So is it the x value or the y value that we need to change the sign? X value. So, not that I want to graph this thing, because I don't like where the vertex is, but where is the vertex? -4 and 75. It's a good thing we're not graphing this. I don't feel like drawing a coordinate system that goes all the way to 75, but that is where our vertex is. I don't care what kind you're dealing with. Once you get that vertex, you do get the axis of symmetry for free. You just need to remember that it's not a number. It is an equation, and it's a vertical line. So it's x equals -4. And once you know the vertex and the way that the parabola opens, you can give the range. Does this one go up to infinity or down to negative infinity? Down to negative infinity. And the highest it ever gets to is the vertex. And what is the y value of the vertex that it actually reaches? 75. So yeah, it is not a coincidence, just so when you're looking at this later, you remember that that number is that number, and that number is that number. I just really wanted a chance to use my smiley face and a star again. The y-intercept, and I'm so adamant that I don't want you to put this, is not 0, 75. The y-intercept is actually the one thing that's harder to find when it's in this one right here. Because the way you find a y-intercept is you do plug in a 0 for every single x. But when you plug a 0 into every single x with this form of equation, it doesn't just destroy everything but the number at the end. Because what's going to happen is inside those parentheses, you're going to get 0 plus 4, which doesn't go away. What's 0 plus 4, everyone? 4 squared is what? So we get -3 times 16 plus 75 equals -48 plus 75 equals 27. So the trade-off for having the vertex being easier to find on this one is that the y-intercept is more difficult to find. If they were both easy to find in one form, then we'd always use that form. But X-intercepts. As this thing looks right now, we cannot use the quadratic formula or try to factor it. It is not set up for either of those things to happen. What is our best bet for trying to find the x-intercepts of this thing? Solve for x. And what technique do we finish up to do that? There was a long technique we used to find x-intercepts. It took a while to do. Most people don't like it. Calling completing the square. Now this one has already had the completing the square started. So the way we solve for x on this one is we will subtract 75 from both sides of the equation, and that will give me this. Then I will divide both sides by -3. And this is not the only way. What you could have done is you could have multiplied it all out and then used the quadratic formula, or you could have multiplied it all out and tried to factor it. But I think since it's already been started, the completing the square process, it's easier to do it this way. Because once we get down to this step right here, we apply the square root property. And applying the square root property basically means taking the square root of both sides, but you get a plus minus out of the deal. So we get x plus 4 squared with a square root, and we get plus or minus the square root of 25. Meaning we get x plus 4 equals plus or minus 5. Don't blow this on the last lap. One of the mistakes I see people make is they forget that when that 4 goes over there, it has to change signs because you're subtracting 4 from both sides. So please make sure that you subtract 4 from both sides. And then your two answers are -4 plus 5 and -4 minus 5, giving you 1 and -9. And if those are your zeros, then your x-intercepts are 1, 0 and -9, 0. What's my point with these last two exercises? Quadratics were a big part of what we did in this class. We spent like 2 whole days doing just quadratics. So, of course, I'm going to ask you about quadratics somewhere, or maybe multiple somewheres on this exam. And we haven't done them in a while. So it's very, very easy to forget some of the subtle rules that are involved with things like domain, well, not domain necessarily, but direction it opens, the vertex, the axis of symmetry, the Y-intercept, X-intercepts. So make sure you go back and revisit this stuff. Because if this went fine for you just now and you're like, that's great, then you're probably in good shape. But if I kind of blew your mind up here with some of this stuff, then maybe you want to look at quadratics again before the test. Cool or not cool? You all right? Okay. Let's take a look at number 7 together. Let's take a look at number 7. Kind of jump around here so this doesn't get stale. It's the big table there, everyone. And let me actually make a few comments before we do this one. Exponential and logarithm graphs each came in 2 basic varieties. Depending on if the base was larger than 1 or between 0 and 1. So exponential and logarithms graphs basically came in 4 different varieties. What we had, everyone, was we had exponential graphs that either looked like this or like this. And the way you knew which one it looked like was the size of the base. Logarithm graphs basically either would look like this or they would look like this. And once again, it was all about the size of the base on them that told you which one it was. So what this table on here actually represents is it represents each of these 4 kinds of graphs by the different bases I selected. So everyone, this first one right here, the base is e. What is e approximately equal to, everyone? 2.7, yeah.
Yeah, 2.71828, right? Or is it
Yeah, 2.71828, that's great, yeah.
Yay.
Good. Although if you had said 3, you'd actually still be able to do this problem correctly. Because what I really care about for this particular exercise is that base is bigger than 1. It's an exponential function with a base bigger than 1. So which one of these 4 graphs is it if it's an exponential function with a base bigger than 1? First, second, third, or fourth? It is the first one, yeah. This is an exponential function with a base bigger than 1. And once you know that, you could give the domain and range. Because does that go left and right forever? All exponential functions do. It doesn't go up and down forever. It does go up forever, but it never touches what? What does it never quite get down to? Yeah, the 0, the x-axis. So that's why the range is 0 to infinity. Does that exponential function have a horizontal asymptote or a vertical asymptote? Which one does it have? It has a horizontal. So it's going to be a horizontal asymptote of y equals 0. And an intercept. Which axis does it hit and where does it hit it? It hits the y-axis at what ordered pair? 0, 1. Well done. So the rest of these on here represent the other 3 kinds of either exponentials or logarithms. And what I would recommend you do is you figure out what the picture looks like first. And then the picture can probably help you answer the rest of them. So see if you can fill in the rest of this table for me. See if you can fill in the rest of this table for me. So here's our filled in chart. I'll just restate. Domains of exponentials in general are negative infinity to infinity, and the range is 0 to infinity. Logarithms in general, the domain is 0 to infinity, and the range is negative infinity to infinity. Exponentials will have a horizontal asymptote. Logarithms will have a vertical asymptote. If you're not shifting the functions around at all, then exponentials should have the Y-intercept 0, 1, and logarithms should have the X-intercept 1, 0. And once again, here's a little tip for you. If the base is bigger than 1, then you know it's going to be an increasing graph. Now, none of these up here are inverses of each other. But they all have an inverse function. They're all one-to-one functions. And the inverse of an exponential is a logarithm, and the inverse of a logarithm is an exponential with the same base. So, everyone, see if you can write down, if you haven't already, the inverse function for each one of these. Take a guess. It is okay to get it wrong. You can scratch it out or print out a new copy later. But take a guess. Maybe you'll get it right, maybe you'll get close. See if you can write down the inverse function. This is not a 4-step process. This is a question of going from exponential to logarithm or logarithm to exponential with the same base. Just got to remember how to do it. If you start with an exponential, your inverse should be a logarithm. If you start with a logarithm, your inverse should be an exponential. F of x is the exponential function e to the x. Its inverse is the logarithm function with the base of e. Most people do not write log base e. What do they write instead? ln of x. Good. The second function up here is a logarithm function with what secret base that you can't see? 10. Its inverse, therefore, is an exponential function with that base, 10 to the x. The third one is an exponential function. Therefore, its inverse is a logarithm function. Here's a good way to make sure that you use your notation correctly, everyone. You write log, then you can put the little 1/3 down there below the line, so I know it's a subscript. And then you put the x up here on the line with the log. That's a good way to make sure you don't mess up that notation. The last one's a logarithm function with a base of 1/2, so its inverse is an exponential function. You should put it in parentheses, so people know that the x power applies to both the numerator and the denominator, not just the numerator. that's going to bring us to our halfway point class. After break, we'll do some more practice together. So a couple things. First of all, our friend Rachel has pointed out to me that on one of the hyperbola questions, I asked for the transverse and major axis, but we don't use the term major axis for hyperbolas, so it should say transverse and conjugate axis. So obviously I did some sort of cut and paste thing and forgot to change one of the words. So make sure you understand that when you have a hyperbola, you are not looking for a major or minor axis, you're looking for a transverse and a conjugate axis. The other thing I wanted to check before we move on here to the last half of class was to figure out if anyone brought questions today. I don't want to ignore anyone. And you were not requested to bring questions, you were not required to bring questions today, but I know sometimes people do bring their questions for review. So give me a hand, and I don't need to see any hands if there are none, but give me a hand if you did bring a question today you were hoping to have answered. If not, we'll just press on with this. Oh yeah, what's up?
I'm a little confused on the hyperbolas. I don't even know what it's referring to. I can't remember the equation to y equals.
The plus or minus?
Yes.
The asymptotes?
Yes.
Why don't we do the hyperbola one together? Let's do number 11 together, everyone. Since I made a mistake on the question, why don't we do number 11, and we'll make sure that we're all feeling good about that. And if this does not answer your question about the asymptotes, then we will make sure we do another example that does. Sound okay? All right, great. So in general, when they ask me to graph a hyperbola and then ask me all these other questions about it, I think it's best to start with the graph. So let me go ahead and get my coordinate system up here. You should already have one. Copy. Whether or not you're drawing an ellipse or a hyperbola, you start by making your 4 key points. The thing that makes it a little bit trickier with the hyperbola is you do have to make sure what number you're using, because the number under x squared always tells you how to move left and right when you take its square root. And the number under y squared always tells you how to move up and down. But with a hyperbola, the y squared can come first. So, because y squared comes first in this one, the square root of 36 is 6. We're going to move up and down 6. And since the square root of 16 is 4, we're going to move left and right 4 to get our 4 key points that will help us draw our fundamental rectangle. It is so easy to get those backwards when the y squared comes first. Because with an ellipse, x squared always comes first. So it's very, very easy to get those backwards. It's actually one of the main mistakes I see with hyperbolas is people have their fundamental rectangle oriented incorrectly. Once you get those points by going up and down 6 and left and right 4, we'll draw in our fundamental rectangle, and we'll draw in our 2 asymptotes. So make sure you do your best to go through the center of the hyperbola and through the corners of the fundamental rectangle. Yeah?
Just double checking, if it was a solid line, any of those dashed lines, that would be wrong, right?
The reason we make them dashed is because they are not actually part of the hyperbola itself, so we don't want to confuse them with the actual graph. So if you did them solid, I would say that is not good practice, but if everything else was perfect, I probably wouldn't mark you off for that. But I would make them dashed, especially the asymptotes, because asymptotes are traditionally dashed lines. But if you flip out on the exam and you did everything right except you made these solid, I'd probably let you get away with that because it stings to miss a point just because you drew a solid line instead of a dashed line. While we're here, before we clutter this up with the hyperbola, why don't we do our asymptotes right now, because they're up there. So, here's your rule with your asymptotes. There's 2 of them. They're lines. And they both have an intercept of 0, 0. So therefore, the only thing you need to figure out is what fraction goes right there. It's going to be plus or minus some fraction times x. And some people are more comfortable doing this. Making 2 separate ones. And that's okay, one with positive, one with negative. However you want to do it is fine. But the fractions can be the same, and here's how you find it. You start here at 0, 0, right in your center, and you find your rise over your run by going up to the upper right-hand corner. of the rectangle. So here I am going up how many, everyone? And over how many? 4. And I do not need you to reduce on the test. If you want to just say 6/4, I am done with this problem, that's fine. Up 6 over 4. If you want to reduce, I of course will not mark you off if you reduce correctly. Please make sure you don't forget to put the x on the end though. I'm not just looking for the slope. You need the x to make it the diagonal line. Otherwise it's a horizontal line. So just up and over. Does that help? Is that cool?
That makes total sense.
Okay.
The homework was confusing.
Yeah, the homework sometimes uses a formula, which I don't usually teach because it's a little bit confusing. And then sometimes once you get the whole graph cluttered, it's kind of hard to find it. But I think, while this is not the only way to find the asymptotes, I think this is the most straightforward way to find them. All right, are we cool with that? Do we know which way this hyperbola opens? Left and right or up and down? Up and down. Not from this picture. The reason we know it opens up and down is because you looked at the original equation. You saw that y squared came first, and so you know it opens up and down. So that's why this point right here is a vertex, and this point right here is a vertex. And then make sure you touch that point. And I want to show you something before I draw in my hyperbola. Look at this, everyone. Let's say we want to find the foci. Now, I can't remember. Maybe you can help me out. For a foci for a hyperbola, is this where we add these two numbers, or is this where we subtract them? We add them. So we do 36 plus 16, and that gives me 52. So are those my foci, 52? I got to square root the 52. And then, that's not even enough. I have to write them as ordered pairs. Everyone agree with that? So it's going to be 0 plus or minus the square root of 52. Why did I know it was 0 first and not 0 second? Because they're up and down. Now, if for some reason you decide to put your foci on here, which some people do, and that's not wrong, but if you decide to actually put your foci on here, then you might make the mistake of going through that instead of your vertex when you draw your hyperbola. But please make sure it's your vertex you hit, not your foci or focus. So when you draw in your hyperbola, hug those asymptotes, but don't touch them, and make sure you hit your vertex, and make sure you put the arrows to show that the hyperbola keeps going, and you'll be fine. Cool or not cool? Everyone getting that? Let's answer the other things it's asking for. Everyone go ahead and on your own, I'd like you to write down the domain, the range, the length of the transverse axis, and not the major axis, but the conjugate axis. There is no major axis. Just the lengths of them. So everyone jot down your domain, your range, and the lengths of those two axes. And then you can look up here and see how you did. Of course, since this is review day, if you didn't get the domain or the range or the length of the transverse or conjugate axis correctly, it's a great time to ask about it. And I guess the only other thing I forgot to do, I showed where they were on the graph, but I never actually wrote down where my vertices were. So my vertices are at 0 plus and minus 6. And that's about all I can ask you about this hyperbola. Question?
That's about the domain range.
Yeah.
So the domain is negative infinity of j because there's no vertices, right?
The domain, yes, the domain is negative infinity because this one opens up and down. If they ever open up and down, that will be your domain. And if it opens left and right, then that will be your range. So for a hyperbola, one of them is always negative infinity to infinity, and the other one always takes a break at the vertices.
I got that. I understand why.
Yeah, so yes, it just is a matter of which way it's oriented. But once again, I don't think I would try to do this unless I was looking at my picture. Because you can absolutely do it without a picture, but I think almost all these questions are so much easier to answer if you're looking at the picture in front of you. Anyone else? Well, while we're on this hyperbola kick, maybe we're not on a hyperbola kick, but I feel like we are. Let's go look at number 15. And let's see here. Oh yeah, I just called the wrong thing. All right. So these are both describing hyperbolas. And I actually set this up in a way so the first one should be easier than the second one. The first one should be easier. So definitely try the first one first. Try the first one first on number 15. And I think it is a good idea to sketch a little picture. Your picture should be able to tell you something like which way it opens. That will get you started. So see if you can do number 15, the first part. With a hyperbola, it's really, really important to figure out which way it opens, either up and down or left and right, because otherwise you won't know which order to write your equation in. Whether you should be writing the y squared first or the x squared first. So with a hyperbola, I would say almost your top priority is figuring out which way does this thing open. And the vertices should tell you that. One of the both guys can tell you that. And I think I've got my answer. If someone wants to look up here and double check to make sure I got it right. As I said, this is review day, so if that's not making sense to you, we need to figure out why right away so we can help you out. So is anyone stuck on that first hyperbola problem? If you can do these without a picture is not required, just the picture really, really helps me. But I'm sure some of you are getting comfortable enough with hyperbolas that you can do it without a picture. That's great. But there's no awards on a test for not showing your work. So if it helps you, you should definitely do it. Are we ready to try the second one? Let's try it. See what you can do with the second one. If you haven't already started it, please start it now. And this one's the harder one. This one's got a little bit more going on with it. figured out what my equation should look like. You want to look up there and double check, make sure you have your equation in the right order. I figured out that part. Are there any tables that didn't get the attendance sheet? Because this one gives you the foci, it does not directly give you any information about your conjugate axis. So for this one, either in your head or on your paper, however you do it, you're going to have to use that a squared plus b squared equals c squared formula to find your missing value. You can get a from the picture because a is the distance from center to vertex. You can get c, because c is the distance from center to focus, and therefore you can get a squared and c squared. And if you know a squared and c squared, and you know the formula a squared plus b squared equals c squared, then you can figure out what b squared is. Then it's just a matter of figuring out where you put your numbers, because the two numbers you need to use are 16 and 20. Now the 16 we got from this 4. And was that 4 left and right, or was it up and down? That was left and right. So this, since it came from left and right, that tells us that the 16 goes under x squared, and therefore the 20 goes under y squared. It is not a good day to be shaky on why this happened. So if you don't like what we just did, even if it was some step we did right at the very beginning, please let me know. Even if your question is, how did you know it was a hyperbola, or, well, I knew it was a hyperbola because the instructions said find the hyperbolas. Also, if it's mentioning a transverse axis, that's how I know it's a hyperbola. Question?
It's a hyperbola, is it always a minus sign?
Hyperbola will always have a minus sign. Your job, the hard part, is the first thing you need to figure out is, does the x squared go first or does the y squared go first? Yes, you're going to have the minus for sure. But with a hyperbola, it makes a difference what order it's in. With an ellipse, you can always just write the x squared first because it's plus.
The ellipse is always a plus?
Ellipse is always a plus. You want to try the two ellipse ones, everyone? That'd be a good use of our time. Let's try your ellipse. So these are actually the one right before the one we just did. These are number 14. So doing it in a slightly different order than I wrote it on here, but that's okay. Once again, I tried to make it so the first one was easier. The second one's a little trickier. Oops. But for both of them, I do recommend you draw a picture. But I do believe the first one's a little bit easier, so I would do that one first, warm up with that one, and then try the second. Just knowing the minor axis is 12 units long actually doesn't tell you what the minor axis is. But once it tells you what the vertices are, The vertices are up and down. So if the vertices are up and down, that means the minor axis is left and right. Because it's always the major axis that connects the vertices. Using that the vertices are up and down, the minor axis is 12 units long, you can actually get their 4 key points on your ellipse. And from your picture, you can deduce that from the center, you're going up and down 9 and left and right 6. You square those numbers, 6 squared is 36, 9 squared is 81. And the reason you put the 36 under the x squared is because it was left and right 6. And the reason you put the 81, or the 9 squared under y squared, is because it was up and down 9. If you see a mystery or a secret or something up there I am keeping from you, I would love to hear about it now so I can help you. If you're too shy to bring it up in front of the class, which I hope you wouldn't be, because no one will laugh at you if you ask, remember, Rachel's got a 2-hour session right after class today. You can ask her, she can help you out. If you haven't already, start that second one. Little tip for everyone though, remember ellipses always have a plus sign. So we can always write the equation right off the bat with an ellipse, because we don't need to figure out which one comes first, because we can always write the x squared first. So ellipse is a little easier than a hyperbola, because we don't have to figure out that first thing about what order it goes in. When you are all done, you can go ahead and look at the board. All right, sorry. So don't look up until you are ready to check your work. By all means, if you see a mystery or a secret, something you're like, Steve, what? How did you know that? How did you make that connection? I'd love to help. Yeah, what's up?
So if the negative sign is on both sides, you just cancel it out, like with negative b squared equals to negative 64?
So what I actually did, right here you mean? Mm-hmm. What I did, yes, was I ended up subtracting the 100 from both sides, so I got negative b squared equals negative 64. And the way it cancels is you can either think of it as you either multiply or divide both sides by negative 1. The other thing you could think of is you could add the b squared to both sides and add the 64 to both sides. But yes, in short, what you're saying is right. If both sides have the negative in front of it, you could just lose the negatives. Yeah. Anyone else? So do we feel better about these than what we did maybe when we first learned them? Drawing an ellipse or or writing the equation of ellipse or a hyperbola from some information? Usually it's pretty dicey when you first learn it, but after you practice the homework a little bit and let it digest a little bit, it usually goes a little bit more smoothly. All right. What shall we do next? Does anyone have a preference of what kind of topic they want to look at next or something? All right, number 13. And remember, anything we don't get to on here, you can look at later. Some of these have more than one possible answer, though. We'll talk about that a little bit before we leave today. Here's number 13. We're going to graph a polynomial. And you remember when we did this before, we don't really care about scaling on the y-axis. All we really care about is, do we get the right behavior at our ends, our right end behavior, and the right behavior at each one of our x-intercepts. So, let's talk about where we're going to hit the x-axis. At what values are we going to hit the x-axis? Can someone tell me? -3, 5, 1, 2, 3, 4, 5, and -2. Which one are we forgetting? Y0. Why is that one of them? Not because there's a number in the front, because there's x's in front. Yes. So the reason we have it right here is specifically because of that x squared in front, not the 4. The 4 is the leading coefficient, which is going to help us figure out our end behavior, but that's not the reason that we have an intercept there. So is everyone cool with all 4 intercepts? Does everyone understand why we have the 4 that we do have? Okay, now, let's talk about what we're going to do at each one of these intercepts. Here's the one at -3. That came from this one right here. What do? Do we cross, do we bounce, or do we cross and flatten? We cross and flatten. Why? Because it's odd and it's not 1. It's an odd number bigger than 1, like 3, 5, 7. So that's why we're going to cross and flatten at that one. What are we going to do at -2? It's got an even multiplicity, so what will we do? We will bounce. What will we do at 0? Bounce, because it's even. And what will we do at +5? Cross, because it's 1. The degree, making sure you add up all the powers, including any invisible 1 power, is what? What's the degree of this sucker? 8. Yes. 2 plus 3 plus 1 plus 2 is 8. And the leading coefficient is just the 4, not the 4x squared, but just the 4. All right, let's think about this, because we need to remember what the end behavior is going to be. This thing is even degree. Even degree. Aren't parabolas also even degree? And they either go up on both sides or down on both sides if it's even degree. So this thing's going to do the same thing on both sides. And if it's positive, what do you think? Up or down? Up. So this thing is going to go up on both sides. So what I need to do, as careful as I can, is I need to start up here, come down, do a cross and flatten, and then do a bounce, do another bounce, and do a cross. Let's see what we got here. Cross and flatten means I come down like I'm going to do a bounce. Like I'm going to do a bounce, but I don't. Then I come back up nice and smooth so I can do a bounce there. Keeping it nice and smooth. Come up nice and smooth and do a bounce here. And the last one's going to be a cross, so just keep it smooth. It doesn't matter exactly how low you go, but do keep it smooth. Just write that up there so you can reference that later. Yeah, because the degree was even, and leading coefficient was positive. That's why we went up on both sides. All right, so there's the picture, but you also have the picture on the answer key. Now you also have the equation also. Sorry, I left that off, but you have it written down now, so you can do it again if you want. Does anyone have any questions about that one? So one thing I want to talk about before we move on is some of these problems on here have multiple possible answers. So let me just kind of talk about those real quick. If you look at numbers 5 and 6, number 5 and number 6, and I believe there's some more, and number 8. Number 8, 5, 6, and 8 all have multiple possible answers. There's actually an infinite number of ways to do these things correctly. So when you're talking about the end behavior of a polynomial, like you're doing on 5 and 6, then basically you're trying to make sure you have the corresponding degree that you need and the corresponding leading coefficient that you need to get that end behavior. So just so you know, like on number 5, what you have to do is you have to make sure you write a polynomial. It has to be unfactored. It has to have an even degree and a positive leading coefficient. I believe I also, to make it more interesting, said your degree had to be at least 3, so it has to be bigger than 3. Now, if you're curious, that first one on there, that first one that has this end behavior, this would be the easiest answer you could give. Because that is an even degree, it's bigger than 3, it has a positive leading coefficient, it does have that end behavior. But if you look at my answer key, you will see I just went a little bit more nuts and did something like this. This is not what I did on my answer key, but. Because that also is an even degree with a positive leading coefficient, and it has the same end behavior. So this was more just sort of an exercise to get you to think about what is the characteristics I need, or what are the characteristics I need to get the equation or to satisfy what Steve's looking for. Number 6, for instance, if you look at this one right here, then what we need is we need a polynomial that is factored, has an odd degree, and a negative leading coefficient. So let's just do one with at least 2 factors here. So if you want a factored one, here we go. X plus 4 and x minus 6. Now, if Steve's requesting an odd degree, we need to make sure those add up to an odd number, the powers on them. Right now, they only add up to 2. So you can just do this. 5 and 10. Is that now an odd degree? Yep, it's factored. It's got an odd degree and negative 2. Would just a negative sign work? Yeah, here's another example. You could have done this also. Or you could have done this. Negative x times x plus 1 to the 4th. That one works just as well. Negative leading coefficient, odd degree, because 1 plus 4 is 5. That one works just as well. So when you're doing those, please pay attention to the answer keys. The answer key on mine, I just did one of each, and I just said, here's a possible answer.
So then would the previous one be an even degree?
This one right here?
Yeah.
No, that's not an even degree because there's no x in front. So you're only adding the powers here. So it's just 5 plus 10. Cool? Let's do one similar to number 8. Let's just see how well we do with our rational functions here. So this is, we'll call this number 8 alternative. If Steve asks you to write a rational function, here's what you need. The f of x equals some fraction, and not just a number on the bottom. Otherwise, we call it a polynomial, not a rational function, so we're not just going to put a number on the bottom. Now, if you understand how vertical asymptotes work, with the exception of you not wanting to take the time to write them all, you can write one with as many vertical asymptotes as I want you to. Because if I say that I want vertical asymptotes of x equals 5, x equals 1, and x equals negative 3, can you write a rational function for me that has those vertical asymptotes? Yeah, you just turn them to factors and you put them on the bottom. That's where vertical asymptotes come from. So if this says I want these vertical asymptotes, then you just go like this. Now it's got those 3 vertical asymptotes. The only thing you need to make sure you do is don't put a matching factor on top. In other words, when you write your numerator, don't put one of those same factors again. Here's the easiest thing to do. You're allowed to just put a number on top. That's how you find vertical asymptotes. You just look for the numbers that make the bottom equal to 0. How would you write a rational function? So don't give me an example. I want someone to explain to me how I do it. How would I write a rational function that has a horizontal asymptote of y equals 0? I don't care about the vertical ones. I don't care about intercepts. I don't care about how nasty the graph looks. All I care about is, can you give me one that has a horizontal asymptote of y equals 0? How would I do that? Yeah, back here. So just tell me what I would do. What's the rule I would follow? You could put an x on the bottom. What do you want to put on top? That would work. And why would that work? I'm sorry.
There's nothing you can plug into the y?
That's not necessarily why, but this is a correct answer. I'm just curious why it's correct. If you want a horizontal asymptote of y equals 0, what feature, or what does your equation need to have?
The denominator needs to be higher.
The denominator needs a bigger degree, which is exactly what you did. You have a bigger degree on top. I'm sorry, on the bottom. As long as you have a larger degree on the bottom, then you are guaranteed a horizontal asymptote of y equals 0. So your answer was correct. I was not trying to pick on your answer. It's a good answer. But that's how you can ensure that you have that horizontal asymptote of y equals 0. Degree on the bottom's bigger, and you got it. This one's a little trickier. How do we make sure that we have a horizontal asymptote of y equals -4, or any specific number? What do we need to do? Yeah?
Have an, on the bottom, have an x plus 3. And as like,
That's,
in parentheses.
okay. And then what would you need on top?
1.
That's not going to give us a horizontal asymptote. No, not quite.
The degrees have to match.
The degrees do have to match. So can you turn this one into one that will work for us?
An x on top.
You put an x on top, and then what do you need in front of that x?
4, -4.
You need a -4. So here's what you need, everyone. You need the degrees to match, and you need it so the leading coefficient of the top divided by the leading coefficient of the bottom equals that number that you're looking for. That's how you do it. So we got it together. That's good. That will take care of it. So anytime the degrees match, you find the horizontal asymptote by dividing the leading coefficient. So if I said I wanted one at -4, then just make sure you have the same degree on top and bottom, and make it so when you divide the leading coefficients, you get -4. What if I want no horizontal asymptote? How can I take care of that really quickly?
The bottom is bigger than the top.
Say that again. Try it again.
Top is bigger than bottom.
Top needs to have a bigger degree than the bottom. So these problems were just to get you thinking about how those horizontal asymptotes and vertical asymptotes work. Because if you can write an equation that has a horizontal asymptote that I specify, then you can definitely look at an equation on the test and tell me what its horizontal asymptote is. I think it's harder to go this way. So just so we're clear, everyone, if you look at the very first problem on this, you will not be filling in a table like number 1 on the exam. But you may have 1-point questions about these functions. That's why I want you to fill in that table on number 1, which we don't have time to do all of it right now, because we only have about 6 or 7 minutes left. But you want to know those basic functions. You'll notice that I even included the function 1 over x on there, because you might see a one-point question that just says something like this. Give the range of f of x equals x squared. And if you know how to fill in this table, then you can give the range of f of x equals x squared. What is that range? Try again. Range, not domain.
0 to infinity.
0 to infinity. Am I including 0?
Yes.
Good. Yeah, got to pay attention. Yeah, and that's one reason we practice. I'm asking for range or domain. Or maybe something like this, everyone. Give the domain of the square root of x function. What's that domain? That's also 0 to infinity, yep. So if you're filling out this table later and it takes you like a half hour to fill it out and you say, I can't believe he's going to put this on the test. No, I'm not putting this table on the test. I'm not putting this big chart on the test. But I might ask you questions about the basic functions, and this is a good way to learn your basic functions. So sometime between now and 10:30 on Thursday, make sure you have no problem filling out this table. And don't ignore the several ordered pairs part. Because the several ordered pairs is very crucial to know if you're going to do a problem like number 12. I'm going to read you something from your study guide if you haven't looked at it yet. I want you to hear this. Here's something it says you should know for your test. Graph sketching. Know how to do the transformation of a basic function, especially the square root graph and the absolute value graph. What I'm implying there is if I give you a transformation to do on the exam, it will probably be one of these two functions, either square root or absolute value. So, which one do you want to do, F or G? Anyone care?
F. No, G.
All right. Now, let me be very clear on these transformation problems. And of course, I don't mean cheating when I say this. That's what I mean that's not what I mean when I don't mean like look at the other person's paper next to you. What I mean is do whatever you can. If you cannot remember how to do the transformations like we did them in class, start plotting some points. Don't freak out and say, I cannot remember the exact way Steve did this, so I'm just going to leave it blank. Look at this thing and say, all right, I do not remember how Steve said to do this, but I can see that if I plug a 1 in here, 1 plus 3 is 4, and I can take the square root of 4 and I'll be able to get a good ordered pair. So do whatever you need to do to get that graph on there, even if it's not the way we learned it in class. The way I taught you how to do it in class was I told you to start with several basic ordered pairs. And then one by one, transform those ordered pairs. So what you do is you subtract 3 from x, you would multiply y by -2, and you would add 5 to y. I'm not going to bother doing this whole problem right now because the answer key is available and it tells you all the steps. But if you don't remember this, if you're just like, shoot, I forget how to do this, then think about, what do you know? Well, you know that it's a square root, and maybe you remember that the original square root graph looks something like that, so your graph's got to have that kind of shape. Then, maybe you just start picking some numbers that you can see you can plug in here. Other than 1, what would be a good number to plug in there?
2.
If you plug a 2, I don't know the square root of 5 off the top of my head, so try another one for me. 6 would be a good one to plug in there. Because if you plug a 6 in there, you're going to get a good ordered pair. Is there a negative number you could plug in there that might help you? Negative 2 would be a good one. Or even negative 3 would be a good one. So I'm not saying you should just randomly start plugging numbers in here. What I am saying is, if you forget the main way I taught you how to do something, take a guess, take a shot, skip it, and come back and do it last. But don't just leave it blank. Don't make my job easy by saying, oh, you left it blank, it's wrong. Class, we are out of time. Rachel's got her session today for the next 2 hours. So if you have any questions that I didn't answer, let her know. If you have a question for me, email me. And please email me by tonight if you need me to bring a calculator to the exam for you.